Welcome back, Night Owls. This is Dr. Nighttime, and tonight we are addressing a physics problem that talks about the best angle to pull a sled. Setup is you've got a sled on some snow with some friction, and you're trying to pull it at constant speed with the minimum force. So, the official problem statement. You pull a 40 kilogram child on a 10 kilogram sled on snow that has a coefficient of kinetic friction u sub k equals 0.20. You do not pull perfectly horizontally, but at an angle theta up from the horizontal. What should theta be to minimize the amount of force you must apply to pull the sled at constant speed? What is that minimum force? So, the first thing we do on a problem like this is we draw a free body diagram. So, we've got the 50 kilogram kid plus sled combination, right? Obviously, those two can temporarily be viewed, and for the duration of this problem, they can be viewed as a single lumped mass. So 50 kilograms of kid plus sled. They have a weight of 50 kilograms times g pulling down. Because the ground is perfectly horizontal, the normal force pointing up is also 50 kilograms times g, right? The sled isn't crashing into the snow and it's not flying off into space. You're pulling it forwards at some angle, right? Hence the force F over here. And, of course, you've got friction that always resists motion. I've got big F for the applied force, little f for friction. And we know that little f equals 0.2 times n, right? Mu sub k times n, we were given mu sub k equals 0.2. All right. So let's just do our standard force balance. In the vertical direction, we've got the normal force pointing up, and F sine theta, right, if we look back here, F times sine theta is going upward, normal force is going upward, so those are both going up. Going down, we have m times g. So, normal force plus F sine theta minus mg equals 0. Normal force equals mg minus F sine theta. Normal force equals 490. I'm not using the unit newtons here only because I'm using capital N for normal force. If I used it both for normal force and for the unit newton, that could get confusing. So I'm leaving off newtons. Leaving off units for now. So N equals 40 minus F sine theta. In the horizontal direction, I just look back at the picture. I've got F cosine theta going forward and friction, little f, going backward. So I have F cosine theta minus F equals 0. Little f equals 0.2 times the normal force, not 0.2 newtons, 0.2 times the normal force. Normal force is 490 minus F sine theta. I multiply that by 0.2. I get 98 minus 0.2 F sine theta. So that gets me F cosine theta plus what I said F was, or sorry, minus what I said F was, so F cosine theta plus 0.2 F sine theta minus 98 equals 0. This gets me F times cosine theta plus 0.2 sine theta equals 98. So, if I need to minimize F, right, I'm allowed to vary theta, if I need to minimize F, it's a question of when does cosine theta plus 0.2 sine theta reach its maximum value, right? I need to multiply it by the maximum, whereas when I divide through, I start with the minimum force, right? So I'm trying to maximize cosine theta plus 0.2 sine theta. There are a number of ways of doing this. If you have a background in calculus, you can just take the derivative of cosine theta plus 0.2 sine theta with respect to theta, get that the answer is going to involve inverse tangent of 0.2. Okay. You can get that in about 10 seconds. I'm going to assume that you don't have a calculus background. And what we want to do, we want to convert from a sine plus a cosine into have a single sine wave of an amplitude with a phase shift. And to do that, I suppose I have this blue diagonal line and a red diagonal line that are perpendicular to each other. One of magnitude 1, one of magnitude 0.2, and I want to set it up such that the x-coordinate, I'm looking forwards, the x-coordinate of the blue diagonal line is going to be 1 times cosine theta, and the x-coordinate of the red diagonal line is going to be 0.2 times sine theta. And so you realize that I can do this if they start out perpendicular to each other. If this green angle is our theta, then setting it up this way, the blue line segment, the x-coordinate of this endpoint here is 1 times cosine theta, and if this is length 0.2 here, the x-coordinate of this little piece here, assuming this is the origin over here, this becomes 0.2 sine theta. To add them up, I just do a standard vector sum. I complete the rectangle. Right? Would be a parallelogram, but we know that they're at 90 degrees to each other, so I complete the rectangle here. And that gets me 1 cosine theta plus 0.2 sine theta. I want to maximize the total x-coordinate. All right. So if you'll notice, this over here, that's the sum. If I want to maximize the x-coordinate of that, and I'm free to swing this around at any angle, I set it up so that the opposite corner lies perfectly on the x-axis. That gets me that theta has to be inverse tangent of 0.2. So to get this in amplitude and phase form, right, if I'm asking for some angle theta, right, if this is rotated through some angle theta, where is this going to be? Where's this opposite corner here going to be? This where the two gray line segments meet? In polar form, assuming this is the origin, I look at the radius. That's going with Pythagorean theorem. I look at square root of 1 squared plus 0.2 squared. That's going to be square root of 1.04. That's the amplitude. And the phase, if I've rotated by theta, if this blue thing is at an angle theta from the horizontal, then this lags behind by this green angle. That green angle is always going to be inverse tangent of 0.2. So I can say that cosine theta plus 0.2 sine theta is square root 1.04 times cosine of theta minus inverse tan of 0.2. To maximize a cosine, I need to input a 0, so theta minus inverse tan 0.2 must be 0, so theta must be inverse tan 0.2. Comes out to 11.3 degrees, so I should pull 11.3 degrees above the horizontal. And lastly, it asks, what is the minimum force? So, looking back at the original equation, I said f times this cosine plus 0.2 sine thing equals 98. I said that this cosine plus 0.2 sine is square root 1.04 times cosine of some angle. So that gets maximized at square root of 1.04, right? It's maximized at the amplitude of the amplitude phase form of the sum of the sine and the cosine. And so I just get force F times square root 1.04 equals to 98 newtons. So the force equals 96.1 newtons. And that's how you can solve that problem without calculus. As always, if you like the way I explain things and want to arrange private lessons, click the link in the description. And until next time, this is Dr. Nighttime wishing you a good night.